Okay, so today we are going to start. Now, I'm going to be posting, I'm not sure if it's in the module or not, but I'm going to be posting a PDF copy of this chapter. Notice we're starting with section 2. If you want to go back and read through section 1, you can. It's pretty basic information. It's absolute value. It's solving equations using addition, subtraction, multiplication, and division. So I will make sure that that chapter is posted. And if you do want to read through section 1, you can do that. So today we're going to cover exponents. So when you have an integer exponent, you can think of it as repeated multiplication. So if you have a bunch of numbers that you're repeating and multiplying them with the same number that you're repeating, you can write it in exponential form. Now, it's going to be very important, and we're going to talk about this in a minute. If you have a negative number, depending whether or not that number is in parentheses, can change the answer. So if you have the same number and you're repeatedly multiplying it, you can count however many numbers you have, and that becomes the exponent. Everybody good so far? All right. All right, the next one, it says if a is a real number and n is a positive integer, then when you see a number here, the real number a, raised to this power n, it means that you would multiply a, however, whatever number n is. So here, where n is the exponent and a is the base. And this is read as a to the power of n or a to the nth power. Pretty good? Now, if I go too fast and you still need the slide, just let me know and I'll go back. Okay, the next thing we're going to talk about is when we multiply exponential expressions. When you multiply exponential expressions, when the base is the same, you are going to add the exponents. So in this particular example, they have a to the m times a to the n. Notice the base is the same. The base is a. And to figure this out, you would just add the exponents. On the example here, the base is x. So then you just add the two exponents, 3 plus 4, and you write it x to the 7. Now let's do some examples. So here's my first example. Now, we're not going to be using the x for multiplication. You probably realized that after you got out of Algebra 1, when you took Algebra 1, that they no longer used x as a time sign or multiplication sign. They're going to either represent it with a dot in the middle, or they'll write it with two parentheses around the two numbers, or the two expressions. So on this problem, notice my bases are the same. They're the letter b. So then all I have to do is b, and then I will add 7 plus 4, and this becomes b to the 11th power. Over here on part b, when you have two expressions and you're multiplying them, you're going to multiply the coefficients. So I'll do 3 times 4. And then for the part of the expression that has a base that's the same, I'll take those two variables, exponents, and I will add them. And this becomes x to the 5th. So you multiply the coefficients, the number in front of the variable, but you add the exponents. Pretty good? All right. Just check something here. Okay, I just want to pull that up there. All right, can you still see my iPad screen? I clicked around. You can't see it anymore? All right, let me pull it back. How about now? Can you see it now? Oops. Okay. All right. If for any reason it goes out, just let me know. All right, next one. Same idea. We're going to multiply the coefficients. So we're going to do -3 times +4. So a negative times a positive gives me a -12. And then I'm going to add the exponents. 2 plus 4, and I get x to the 6th. Over here, I'm going to multiply the coefficients. -3 times +5 is -15. Then I'm going to add up the exponents on my a's. Now, if there isn't a number, so see how this a doesn't have a number here, you're going to assume it's got a 1. So we're going to add 3 plus 1, and this will become a to the 4th. And then for the b's, you're going to add 2 plus 4, and then this would become b to the 6th. Over here, we have an m and an n. Again, this m here doesn't have a number, so I'm going to put a little 1 there. So this will become m to the 3rd. And then my n's, again, this needs a 1. So 1 plus 4, and I get 5. Part F, multiply the coefficients, add the variable exponents. 3 plus 4, y to the 7th. And then for the z's, again, you assume a 1, and 1 plus 2 is 3. Good so far? All right. Let's try some more examples. Now, instead of just multiplying 2, we're going to multiply 3 things, but the process is still the same. So I'm going to multiply all of my coefficients. Now, see this first expression here? I could assume that there's a -1 here. So I would do -1 times 3 times -2. So I would get +6. Now I'm going to go back, add up all my exponents on my x variables. I can assume a 1 on this one. So 2 plus 1 plus 3, and I get x to the 6th. And then the y's, add those, assume a 1 here. 3 plus 2 plus 1, y to the 6th. Let's try the next one. Again, this one, I can assume that this is really like a -1 in front. 5 times -3 times the -1 gives me +15. Now, if you're multiplying a lot of expressions or a lot of terms, you can also count the number of negative signs in your problem. And if you have an even number of negative signs, then the answer is always positive. If there's an odd number of negative signs, then your answer will be negative. Now I'm going to go back and look for some variables. I've got an a in this one and an a in this one, so I'm going to add 2 plus 3. I like to write my answer, my solution, in alphabetical order. Technically, if you would have written the b first, it's the same answer. But a lot of times on a standardized test, you're going to see the answer written in alphabetical order. Then I can go back, get my b's, 4 plus 1, and this is b to the 5th. Now this is just coincidental that both answers here, the variables had the same exponent. It may not always happen like that. Pretty good on example 2. Let's move on to example 3. Okay, so now you always should follow order of operations. So what you're going to do before you multiply, have you guys heard of PEMDAS before? So we would always need to do the exponent first, then we'll go back and multiply or divide. So what I'm going to do is I'm going to go ahead and apply this exponent first. Notice my negative number here is in parentheses. So what this means to me, negative x in a parenthesis raised to the second power, this means I'm doing negative x times negative x, which means it becomes positive x squared. So I'll write this one down. Just going to rewrite it. I'm going to evaluate this one, and it becomes this. And now I can do the multiplication. So I can think of this as negative 1 times positive 1. So this becomes negative, and then I add the exponents. 2 plus 2, and that's how I get the 4. The next one, again, I'm going to evaluate this first. This is really negative x times negative x times negative x, which becomes negative x to the third. Notice 3 is an odd number, so I know that I need to keep it negative. So then negative x cubed times negative x cubed. Now I do negative times a negative, and it becomes a positive x, and then I add 3 plus 3 and get 6. Good so far? All right, let's move on to example 4. Okay, for example 4, now what I have is an addition sign in between here. Again, I'm going to follow order of operations. So I'm going to multiply each of these on either side of the plus sign. I'm going to multiply them first, and then I'm going to go back and see if I have any like terms that I can add. So again, I am going to multiply my coefficients. So 5 times 2. And then I'm going to add the exponents on the x's. Then I can go ahead and do the other side of the plus sign. I'm going to multiply the coefficients. Get 3 times 4 is 12. And then x to the first, assume a 1 there, times x to the fourth gives me x to the fifth. Now notice both of these terms have exactly the same variable with exactly the same exponent. So I can now go back and add my like terms. I can add the coefficients. So 10 plus 12 gives me 22 x to the fifth. When you add variables that have exponents, they have to be like. So for example, let's say my final answer became 10x to the sixth plus 12x to the fifth. These are not like terms. So if the result of this problem would have turned into this would have been my final answer. X to the sixth and x to the fifth are not like terms, so I could not add those coefficients. The variable has to have exactly the same exponent in order to add those coefficients. Let's try the next one. Again, I'm going to multiply the coefficients. 3 times 5 is 15. And then I'm going to go back, and when I multiply those two variables that have the same base, a becomes a to the eighth. Then over here, again, multiply the coefficients. This you can assume it's a 1, so it becomes 6. And then go back and add your exponents on the letter A. Again, these are like terms. Notice my variables have exactly the same variable with the same exponent. So I can go ahead and add those coefficients, or actually subtract those coefficients. So this would become 9a to the 8th. The next rule we're going to talk about is raising a power to a power. So when you have a power and it's raised to a power, this time we're going to multiply those powers. Okay? So, or if you had a times b, then this power would go on both variables. So these are two different rules. So here, you could assume 1's here, and you could also think of it as multiplying to both. So when you raise a power to a power, you multiply the exponents. So in this example, we have 4 to the 5th, x to the 4th raised to the 5th power. So we're going to multiply 4 times 5, and we get x to the 20th. Now, one other thing I want to talk about before we go on and do the last set of examples is anything raised to the 0 power. I know it's not on the slide, but we're going to add that. So when you have a number that's raised to the 0 power, that is always 1. This is a fact you need to memorize. If I said 1,000 to the 0 power, you're going to memorize that that equals 1. Now, let's say I have a negative number raised to the 0 power. So let's say instead we have negative a to the 0 power. When it's in a parenthesis like this, this is equal to 1. If I did not have a parenthesis around that term, then this would end up being a negative 1. Because what you can think of this as is either think of the negative sign as falling down because nothing's holding it in, and then a to the 0 power is 1, and that's how it turns into negative 1. You could also think of it as negative a to the 0. You could think of this as being a negative 1 in front times an a to the 0, and then this becomes negative 1. This part becomes 1, and that's how it becomes a negative 1. So if there is a parenthesis around a negative number, and it's raised to the 0 power, the answer is 1. But if there's no parentheses around it, the answer is negative 1. Pretty good so far? I can show you with a number also. Let me do an example like that. So let's say I said, let's do 10. 10 to the 0 power. If it's in parentheses, it's still 1. If it doesn't have parentheses and it's positive, it's 1. But if it's a negative 10 with parentheses or a negative 10 without parentheses, the one with parentheses is 1, but the one without parentheses is negative 1. All right, let's try a few more examples. Everybody good? Any questions? All right. All right, so here it's asking us to simplify the expression. So on these, it's a power to a power. So remember, when you're raising a power to a power, we're going to multiply the exponents. Now, this 3 exponent is going to go to the 2, and it's also going on the x. So this would become 2 to the 3rd. And then if you wanted to assume a little 1 there, 1 times 3 is x to the 3rd. You will evaluate this. 2 to the 3rd means 2 times 2 times 2. And this answer would be 8x to the 3rd. Now, let's say you're taking the test and you're like, I don't remember what she said to do. So let me show you on part B here. As long as you remember that squared or to the second power means you could just take this and write it 2 times. And then you could go back and do it if you want. And just remember to add. You could also think, okay, this really means 2, and then x, 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 x. And then this one, same thing, x, 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 x. And then you could go back and just know that all the way you're supposed to be multiplying, count how many x's you have, and you would get x to the 10th, and then multiply, oops, I'm on highlight, and then get x to the 10th, and then multiply the 2 times 2. Now, it's a lot easier. You don't need to do all of that. Just remember that this 2 will go to the 2, so 2 squared, and then power to a power you multiply, so it becomes 2 times 5 is 10, and then you would evaluate 2 squared and make it 4, x to the 10th, same way. Now here we go with the negative. So again, if it's in parentheses and you're squaring it, -2 times -2 is +4, and then 5 times 2 is x to the 10th. Over here, this is to the 3rd power, and it's in a parentheses. So here this would really become -2 to the 3rd, which would become -2 times -2 times -2 is -8, and then multiply 4 times 3. Over here, same thing. This power of 3 is going to go to the -3, the x squared, and the y to the 5th. So -3 times -3 times -3 is -27. Then the x becomes 2 times 3, x to the 6th, and then y would be 5 times 3, and it's 15. Now for this one, let me just add an exponent to this because really there's no work to do on F. But let's go ahead and change this and make this to the 2nd power. So here again, you could think of this as a 1. So -1 squared, that'll just become positive, and then it'll become x squared, y to the 4th. Two more set of examples and then we're done. All right, next one. Again, we need to follow order of operations. So we're going to apply the exponent first, and then we're going to go back and multiply. So this 3 is going to go on this, the 3 base, or the 3 coefficient, go to the A, go to the B. So just simplifying this will become 27, A to the 6th, B to the 3rd. Now I have to do this one. The 2 will go to the 2 squared, A becomes A to the 6th, and B becomes B squared. Now I can go back and multiply. Multiply your coefficients. 27 times 4, 108. Go back, add your A's. 6 plus 6 is 12. And then add your B's. 3 plus 2 is 5. So you're multiplying coefficients, but adding the variable exponents. Next one, apply or evaluate the exponent first. So the 4 will go to the 2, the x squared, the x cubed. So 2 to the 4th power is 16. X squared raised to the 4th power is x to the 8th. Y cubed to the 4th power is y to the 12th. And again, I'm going to evaluate this one. This negative 1 squared is positive 1, becomes x squared y to the 4th. And now I can go back and multiply. 16 times the assumed 1 is 16. Add the x's, get x to the 10th. Add the y's, y to the 16th. For this one, again, you're going to do the exponents, then you're going to multiply, then you're going to add. So multiple steps here. So this one will become first 8 x to the 3rd. This one will become x squared, y squared. Over on this one, there's nothing to raise to any power, so let me just rewrite it. Now I need to multiply. So this one becomes 8, add the x's, x to the 5th, add the y's. There's only one y here, so y squared. And then over here, I can add my x's, and I would multiply the coefficients. So this will become a negative 4, x to the 5th, y squared. Notice my variables, the x and the y have exactly the same exponent, so these are like terms. I can combine these two. So I would add the coefficients. So 8 plus negative 4 gives me 4, x to the 5th, y squared. Remember, when you add like terms, you do not add the exponents, just the coefficients. One more slide. Now, when you have a fraction that's raised to a power, this exponent of 3 is going to go both on the numerator and the denominator. Because if you think about it, this is really 3x over 2y times 3x over 2y times 3x over 2y. So we're going to apply the exponent to both the numerator and the denominator. So 3 to the 3rd, or 3 times 3 times 3, is 27. And then it becomes x to the 3rd. The denominator, 2 to the 3rd, is 8. And then it's y cubed. I can't simplify anything here, so I will leave it alone. Here we go with the negative number raised to a power. So here, notice there's no parentheses around this. So again, you can either think of this as negative 1 times 4 squared. So it would become negative 1 times 4 squared, which is 16. Or again, think of the negative sign falling down, nothing's holding it in. And then this power of 2 is only on the 4, so that's why the answer is negative 16. For part C, this is really negative 4. Well, negative, same idea here. You could think of it as negative 1 times 4 times 4 times 4, which is negative 64. Generally, remember, if the exponent is an odd number and it's a negative number, it's going to be negative. Over here, this one with the parentheses means negative 4 times negative 4, and the parentheses are holding it in. So this becomes positive 16. And then the last one, anything raised to the 0 power is 1. Any questions?